right, so I'm going to discuss about new frontiers in cloud and edge computing. The requirements from this cloud edge computing are driven by real world applications. Particularly, I'm taking from two kinds of application. One is big data. So this big data means massive amount of data. Another one is Internet of Things applications, where real-time requirements are data generated and they need to be analyzed and then response need to be created immediately and rapidly. So these are two classes of applications that we are taking into consideration in this tab. But of course, I will talk about cloud computing, some of the recent advances in this area, then how they are supporting these recent applications that are emerging in the field, in the society, in the government application, in industrial applications. So as Dilip introduced, I am from University of Melbourne. So we have Cloud Computing and Distribution Laboratory at Melbourne University, where we conduct the research. And we also have a company called Manjrasoft. This was a spin-up company from University of Melbourne almost 10 years ago. So where one of the software technologies that we developed is commercially made available, a commercially great solution. So I will discuss about that also as we go along. Okay, so here is the outline of today's discussion. First, I will give you very briefly the different computing paradigms that have emerged during last 50 years, then bring you to edge computing, cloud computing, and IoT. So then we will discuss about cloud architecture, which is market-oriented cloud architecture. As part of the discussion, I will also present a software platform called Aneka that we developed. Then, of course, within that, we'll also discuss the architecture and some of the example applications that of Aneka technology. So I will discuss two classes of application. One is big data oriented. Other is also IoT. Especially these days, applications from AI or deep learning are becoming popular. So I will discuss briefly about a case study on application of Aneka in object detection or deep learning applications. So then we will discuss new trends in this area, particularly introducing you Internet of Things. So that is one of the key topic for today's discussion, and the requirements of this IoT, and then the new computing paradigms such as fog and edge computing, and how they are going to support this IoT application. As part of this, we will discuss about one of the software we developed called FogBus, and I will illustrate that the FogBus architecture and implementation as applied to a application in healthcare. Especially nowadays, the health issue has pretty much controlling everybody in the world. This is COVID, coronavirus. So perhaps that is very relevant to talk about healthcare application. So perhaps we need to extend further by developing some kind of IoT new class of application that could be deployed on Aneka or in FogBus for next generation healthcare. And also I will briefly mention about a simulator called IoT-Fog sim that we developed in order to support modeling and simulation of next generation edge and cloud computing environments, and then simulating application, and also developing new approach towards how to manage multiple users in a given environment to support their requirements, such as quality of service requirement. In this case, quality of services can be time by which you need answers. So then we will conclude, and I'll also briefly discuss about some of the new directions in this area. Obviously, some of you may want to do projects, whether it is a bachelor project or even the PhD project. There are many open issues that can be explored. So to begin with, as you know, so this the computing paradigm.
Like, from your placement.
Hello. Okay, so I hope everybody can hear. Huh? All right. So now, so there are many computing paradigms have emerged. You can see from 1960s to I am projecting up to 2030. What are the different computing paradigms that have emerged? And you will notice, during 60s, as many of you studied in computer history, that during 60s we had computer, they were called mainframes. So here you see a picture of a mainframe computer. So this was very popular model of computing. Then of course later on in 1970s, many computers came into picture because mainframes are very expensive. Often just one or two such big computing system built for the whole country and perhaps made available as a service to users. Then later on, instead of having a big mainframe, the concept of mini computers came into picture between 70s and 80s. So this also was very expensive process, computing system. Companies such as Digital Equipment Corporation, DEC, so they played an important role. So IBM was primarily credited with mainframes, then mini computers was credited to Digital Equipment Corporation. Then later on, client-server computing came into picture. So client and server, that means there'll be a big server, then multiple client computers at offices, they can connect to big server and start using it. That's called client-server computing. Then came World Wide Web. So rather than having a server and a client in one organization, you can have a servers in somewhere remotely that can be used for serving especially remote content, for sharing documents in large scale. That World Wide Web came into picture. Of course, during the last 25 years, we saw many advances in the name of web, such as web services, service-oriented computing model. So that has become popular as a result. Now you can build applications. So I can build an application running on my computer. You can build a new application running on your computer. You can expose that capability as a service. Then somebody else can build a new service running on their computer. They can compose service from 1 and 2 and put together. That is a new service. So this is called service-oriented computing model, service-oriented architecture, and so on. Then, of course, during the last 10 years, we saw growing popularity of cloud computing. So essentially, making computing as a utility. So just like when you build a house at, say, for example, in Mathura, so you don't have to dig a well. Instead, you can connect yourself to the water supply board. Then you just consume the water and pay for what you consume. That is called utility model. And the same thing is true with electricity. And the same thing is true with networks and mobile phones. When you buy a mobile phone, you don't build a network of your own. Instead, you subscribe to a network service provider, such as Airtel or Optus or Telstra here in Australia. Different companies provide that networking service, and they are providing as a paid service. You connect to the network, start using it, you pay for what you consume. So this is the pay-as-you-go model. The same model of computing now come to same model of utility has come to computing. That is through cloud computing. And today, for example, the application of cloud computing, numerous applications. So I will discuss many of those. Many of those applications you are using, and then why we need such a capability called cloud computing to support those applications. And in fact, today we are talking to each other, doing this video conference, which is also enabled by cloud computing. The video conferencing server, this is called Zoom, running in a cloud. Then it can facilitate our interaction. Then it supports reasonable scalability up to people easily doing 500 participants. And also you can store and you can record and play it later. And they also have many replica sites. If one site is unavailable, they can migrate to other places. So all these things are happening, so which is very good. So then, of course, there is a concept of Internet of Things. We know Internet, if you look at the history of Internet, the Internet was created for the main reason for creating Internet was to enable access to large-scale mainframes as services. Because as I said, in 60s, mainframes are very expensive, just one per country. And everybody cannot afford to buy such mainframe. So at that time, there was a need for network to connect businesses and universities to the mainframe so that they can use computing services. So that was the vision with the Internet started. Then of course, this was Internet has grown and grown. Now it became a worldwide network, a network of networks of computers. And now the concept from networks of computers to networks of everything. So we want to make everything to be part of Internet. So yeah, we will discuss about the IoT. Then as this Internet of Things becoming very popular, then the current model of computing face challenges, unable to support them. Therefore, we now have a new model called fog and edge computing. So we'll discuss all of this concept as we go along. This edge computing, fog computing is a bit more recent innovation and now rapidly emerging. and I will discuss about some of the open issues, challenges, the state of the art to begin with, and then what are the open issues. I will give some examples of how it has been done, and there are a lot of opportunities for you to explore in the context of new class application that we can use Internet of Things for creating smart environment. Okay, so this notion of course, now today we make a lot of decisions based on the data. So this is a data-driven world. So in the past, this data-driven concept has been there, especially if you look at big scientific problems such as high energy physics, astronomy, big medical problem. So they had a large-scale instrument that capture massive amount of data, then they're creating like terabytes of data, and then scientists have to analyze that terabytes of data to make some discovery. And for example, this was used in many applications, like for example, high energy physics. A few years ago, like 4 or 5 years ago, high energy physics, they discovered what they called Higgs boson particle. So that was made possible through generating this LHC data. The data is distributed around scientists around the world. They are analyzed using their supercomputers and grid computing, then discovered. Same thing also happened with astronomy community also. Okay, so those are big scientific problem. But now this data-driven concept has shifted towards a large population. So we now have a large population in the world. Of course, they were there, but the technology advances is moved towards how do we support this notion of big data in a large-scale population context, where we can enable many interesting applications such as interesting healthcare application or interesting security application, like security application, very important. Of course, apart from supporting interaction. But now, for example, if you have an IoT-enabled application, so perhaps this today situation of COVID, where IoT is constantly monitor a person, then and then everybody networks, then the data is available as a data-driven world, and they can make a rapid decision on how to manage this epidemic. I think that is something people didn't, no one foresee that such a thing happened. But anyway, now it happened. I'm sure over a period of time, you will see the evolution of this IoT towards such application. This is a great opportunity for some of our students, young brains to think about this area. And coming to cloud computing, as I said, cloud computing offers, utility-oriented services. You subscribe to services and use it and pay for what you consume, just like electricity, telephone network services, and water services. So this is a new class of network. So from network distribution networks to cloud network of services. So here is the high-level view of how the whole thing looks like. And you see that there are set of resources. Here is a cloud called public cloud. So this was set up by some third party. So for example, a company like Microsoft or a Google or Amazon, IBM, someone sets up this facility for you. And you as a consumer on the other end, so you might be using it for different application, enterprise application, business application, or applications in different areas. So you can take those service requirements and then send instead of having application running on your system, you send it to a cloud where actual processing is done, you get back results. And of course, you actually pay for what you consume. So this is a model of cloud computing. So here it looks like as a consumer, you might have subscribed to one service provider. So when you subscribe to one service provider, this doesn't mean that service provider does everything for you. That service provider actually using service of other providers, combining them together and delivering service to you. Say for example, Dropbox. Dropbox is a cloud storage service. It provides you a highly scalable access to services that are distributed around the world. And this Dropbox is a cloud storage. Actually, this company Dropbox.com is essentially a brokering service. And they don't own infrastructure storage themselves. They instead harness the storage from multiple places and offers you unified access to the large-scale storage. So this is what Dropbox has done. And this is the kind of architecture nowadays, more and more cloud technologies will follow. Okay, so that is about how Dropbox or others are moving. So now moving forward with high-level architecture, here in this case, you can subscribe to compute resources, you can subscribe to data resources, you can subscribe to application resources, you can subscribe to storage resources. Based on requirement, you use it and pay for the consume model. So nowadays, there are already various service providers, including storage. You can rent a storage, you can rent compute, you can rent data set, you can rent application, or you can rent all of them together. So this model has now become real. Okay, what are the applications of this technology? So let me highlight briefly the known ones. Then after that, I will discuss about many others that are emerging. Okay, first, of course, the traditional business applications such as customer relations management, the enterprise resource planning, e-commerce. So nowadays they are available as a cloud service already. So which is good. So that is already happening. So moving towards more popular ones are these consumer applications, such as many of you as students are using it. For example, Twitter. So Twitter, just a micro messaging service running on a cloud. So as the number of persons using this can change, accordingly they can provision right number of resource and support application. So this is a Twitter application and service. Then the Dropbox I already mentioned. Even the Facebook is running on cloud, because the Facebook, as you know, users, especially now, number of users joining Facebook is rapid increasing. For example, when I have my Facebook account, so up to now I probably used to have 1,500 friends, virtual friends. Of course, I only knew few people in person. The rest all are just became virtual friends. Then during last 20 days or 30 days, I'm noticing number of people wanting to become friends are increasing every day. Almost 100 new people making a connection. That means everybody held up at your home. What can they do? So they want to know what is happening to other people. So they just create a Facebook page and try to become friend. Like that, they're becoming with me. I already, unable to deal with this virtual friend request already. So this kind of Facebook system, if it is in a centralized place, so it won't be able to offer the best responsive services to you. So therefore, what they did was they created multiple cloud data centers in different places around the world. Then once you log into portal, automatically they classify users and position them into different geographies seamlessly. So this way, all of us get a best response time quickly. Because Facebook is not just posting a message, but also they have to recognize who are the people in the application and what kind of messages you are communicating. Sometimes they also do analytics to find out what are the trends. So this requires massive computing capability, which they build themselves. Okay, those are the applications. Now coming to 2020, just recently we looked at. I actually looked into what is happening on the internet every 60 seconds. In a minute, what happens? So, for example, in 2019 and right now in 2020, in a minute. And you will notice just looking at applications such as this Facebook, Netflix, or Twitter, or Tinder, or YouTube. These are our standard consumer-oriented application, and you can see the massive number of users that use is increasing. So just within last year December, they had 1 million users. 1 million people used to log in a minute. But now, thanks to COVID, within no time, it increased to 1.3. And if you look at today, maybe it's 1.5 million. So people log in at a time. So huge number. And number of messages are broadcasted are massive. And number of people accessing YouTube massive. And e-commerce sites and spending online is a drastic increase. And all these applications, where are they running? They're actually running on a cloud. So because, as you know, number of users that use this can drastically go up and also come down with time. So during peak hours, so it may be a huge number, and during off-peak hours, number of users increasing can be less. So therefore, they must be able to include required capability to that application. In cloud, it is a pay-as-you-go basis, rent basis. You rent a required capability to meet your application needs. So therefore, dynamically, we should be able to change as necessary. This is the on-demand computing system. Okay, and you can see these are huge number of applications. This is what is happening right now. This is just a few days back, I got this data, and you can see in 60 seconds, massive number of users are using cloud services. So which is actually a good thing. Then of course now because of COVID and then this Zoom, almost literally unknown company and unknown service, it became very popular during last 1 year. And you probably heard that even their stock market value stock price, what was some X dollar per stock item, but now it became almost double, triple. On the other hand, all other stocks, whether the banks or many other, they come down where the Zoom went up. So this is a dynamic environment. Of course, they need this very nice scalable environment, and of course security. So there are some security concerns, but we should be careful. And of course, they can be dealt with by our proper implementation. Okay, that is a foundation concept application. Now let me discuss about, as we go deeper inside cloud, what is it like? So, I initially said cloud is a remote service you can rent, but what actually happens inside? So at the top, if you look at layered architecture, so at the bottom, physical machines that are interconnected, and these can be within one place or across multiple places around the world. Okay, so there's a physical machine. At the top, we have users. And of course, users here, there are multiple types of users. The users who want to run application are one type, and users who just want to use application service are another type. Anyway, let us say users who want to use a application service such as healthcare or business or enterprise or analytics application. And these users, when they make a request to cloud, they need to define the requirement. So especially application users. So for example, when we use this Zoom, so we define, so for example, our university got this Zoom account, and they define some of the quality expectation. We are a paid customers. So we define requirement accordingly. First, okay, they have to see how much resource they got, can they admit and honor this request. So here we got, user request comes in. The first, there is something called admission control system. Admission control is applied everywhere. Some places this is just open, some places not. Of course, in this Zoom talk, I just kept open. Anyone who knows this Zoom link, you can join in. But whereas the link that came from your university, they sent you, here is Zoom ID, here is password. So they are doing admission control. Then when I said that, hey, some of my team members want to join for this talk, they said, oh, looks like it's really difficult for us to do. So we open up to everybody. That's why we're using mine. Because I'm a bit more open person, so I don't mind anybody to join in the world who want to hear our talks. So we want to share the knowledge with everybody. So no problem. So there is admission control. So here also in cloud, there is admission control. So you need to make sure that we can really honor the quality that is expected. For example, if I made this Zoom open to all India, we would have 1 billion people who try to join, then we won't be able to serve. That's a challenge. And I'm glad that right now we only have 120 students who are joined. Thank you. So now once we admit a request, in order to serve the request in cloud environment, they don't rent you a physical machine. So there is no physical computer named after you. What they rent you is a virtual machine. When you make a request to cloud, define your requirement, accordingly it will create a virtual machine. So here is the virtual machine that created. Now, once you create a virtual machine, we need to map that virtual machine to a physical machine. And the question is, which physical machine? So for example, let's say all of us are in India. Now I create a Zoom session. They create a virtual machine. And then where do they map that virtual machine? They can either map virtual machine to a physical machine located in Australia or located in India. If as a host, if I was in India, probably they would have mapped that virtual machine to a location in India data center, which is there. Then that way we all be solved very nicely. But of course, here, if it's a dynamic system, they can even do many decision-making process here. So anyway, say virtual machine is created and mapped to physical machine. Then after that, application service is running. When application service is running, so number of users start using this service. Then of course, number of users can increase or decrease with time. Yeah. So when we started our talk, we probably had around 70 students. Then it became 120. Then it became, just now I just saw, it became 117. Maybe it will decrease or increase. It can happen. So sometimes students or somebody want to take a break or somebody knocks on the door. Therefore, you disturb, you disconnect. So this way, number of users can go up and down. So we need to make sure that services are delivered to consumers the best quality. And then for that, if I start running with one virtual machine, that can serve, say, 50 users. But number of users are increasing to 120. Then if I start running that application on one virtual machine, which is meant for 60 students, then what happens? if 120 students join, we start experiencing, slowness in our responses. Maybe you might hear very slow, or maybe a lot of things may not happen. Okay. So this is a challenge. I think some students are raising hand. So they don't need to raise hand. Keep it down. So we will have a question answer at the end of the session. Okay. So you can see number of users increasing and decreasing, and that we see already this dynamism. So therefore, in cloud, we need to provision right amount of resource. The cloud would have a cloud resource manager that monitors how many users are coming in, how much quality of service we promise to users, and are we able to meet the requirement with existing allocation. If not, dynamically add extra resource. Okay, so here you can see when number of users increase, we increase number of virtual machine that we are renting. So now once we increase virtual machine renting again, so the virtual machines that we rented don't have to be mapped to one location. It can be across multiple cloud data centers. So in this talk, we have participants from China, we have participants from India, we have participants from Australia. Okay, so now if it created a few more virtual machines, perhaps seamlessly the cloud platform must seamlessly scale across, place some of those in different locations in a seamless manner without user knowledge. Then of course, in 1 hour time, we are going to conclude. As we come into concluding, number of participants may decrease. At that time, suppose if it comes to just few number of people, we don't want to rent those many virtual machines. We will just decrease it. So that is called decreasing. Correct? So this is called elastic property. You increase number of resources that are necessary, then when the demand decreases, you decrease it. So this property of cloud is very, very important. And the success of cloud is because of elasticity. Okay, elasticity is a very important property of cloud computing. So therefore, some people also call it as elastic computing. In fact, if you look for search on internet right now, elastic computing, Australian government things. Recently because of this COVID, there are a lot of people lost jobs. Then government is providing allowance to those people who lost job. So then many people who lost job, they start registering very heavily into the government system that they lost job, they need a government some payment. So when everybody start doing it, the system becomes so overloaded, the government system broke down. As a result, so many people went and stood in front of the office, and now, of course, this is COVID, social distancing, too many people are crowded there. So then this is where people looked at, hey, if the government has utilized elastic computing services from cloud, we would not have experienced this situation. You can see already we are experiencing. So whenever we have application and the infrastructure that is not designed for this elasticity, we are all failing under this demand that coming from many users, whether they're government services or healthcare services. So the cloud computing is becoming even more popular as a result of this COVID, correct? Everybody at home, and then they cannot go physically to one place, the load get distributed and services are delivered through cloud computing. I hope this concept is become very clear, elasticity, expanding or shrinking as necessary. So this is a very important, please understand this concept very well. So because this has implication on how you build your application. Now you think in terms of software engineering. You want to create an application that is elastic in nature, that can expand or shrink. Let me see who is typing some chat session, whether there is any big issue. No issue, right? Okay. Okay, hopefully no issue. Yeah, sometimes I'm just monitoring what is happening with different participants. Okay, all right. So this elasticity. So let me explain what is this elasticity and why it matters. The first, so because if you provision more resource than you needed, you have to pay for that extra resource. Then especially if you're not using and you have to pay for it, you won't be happy. So therefore, you only want to pay for what is actually needed. Okay, therefore, we need to have a dynamic process of deciding what is needed, what is not needed. So that is called autonomic management of cloud computing. And then, of course, in our real life also, we follow this elasticity. And then how to expand things. I can give you many interesting examples of this elasticity concept. Expanding or shrinking. So this is in computer science. There are two kinds of scalability. The first one is called vertical scalability, and the second one is called horizontal scalability. So vertical scalability is achieved by building faster hardware. Okay. So whereas horizontal scalability is achieved by provisioning extra resources. So in computer science, in IT technology, the virtual scalability was achieved by building faster hardware. That is by building new microprocessors. During last 10-15 years, you might have noticed we have many companies like Intel, AMD, and others. They release different type of microprocessors. Some of them are like initially something like 40 megahertz, then became 1 gigahertz, then became 1.5. Like this, they produce newer microprocessor with higher clock frequency. But they reached a point they are not able to produce anymore faster processor. That means they reach their limit, speed of light and the thermodynamic constant, there is a limit. That means the vertical scalability is stopped. So what do we do? So the next class of architecture is to look into horizontal scalability. So in computer architecture, horizontal scalability is achieved by having multiple processors they are put together. So this is, I can give you some analogy. Like for example, when baby is born, the baby height is maybe 15 centimeter. With the time, baby grows vertically. Like this, it grows. Maybe for around 18-20 years, then it will grow maybe up to the height of say 160 centimeter. Correct? It grows vertically. And how long you can grow more? So we reach the limit. We cannot grow anymore. So for example, I have reached vertically this height. Now, if this is by 20 years stopped vertical growth. And if I want to grow, of course, the desire for growth is not stopped. And how do we grow? Then we start growing horizontally. Correct? So this is horizontal expansion. So this already happens. But of course, this horizontal expansion, how do we shrink? Maybe by doing certain yoga, you can shrink yourself. Generally, it is difficult, but you have to shrink, otherwise not healthy. So it can be expensive to maintain body. And also similar in cloud computing also, when you have multiple resources that are expanded, if you do not release them, they charge a higher price. So you have to shrink them. So shrink it. So this capability is elasticity. So sometimes people like Hanuman have this capability. Hanumanji. So Hanumanji, when he flew from Rameswaram towards Lanka, on the way he come across a demon. The demon, says you cannot really cross me. So she said, okay, so if you can escape, you can cross me. So what did Hanuman do when this demon was open full mouth to eat him? Okay. So
when University की बात कर रहा था, we teach you people because we have gained knowledge for now quite some time.
I think somebody video is still on.
We have studied in our curriculum, so we are taking care of all these things while delivering the lecture. But at the same time, we need to update our knowledge. अभी क्या है आसपास रियल वर्ल्ड में इतनी सारी चीजें चल रही हैं तो उसके बारे में तो
somebody who has okay so there is a you expand, then Hanuman became like a small like a fly, then enter into the mouth of this demon, then demon impressed, let him go. When Hanuman presented himself in front of Ravana, what did he do? They didn't honor him. So he just sat on, he created a chair of himself and sat on his tail. And later on, Ravana put fire to Hanuman's tail. What did Hanuman do? Hanuman just expanded himself, then burned the whole Lanka. So he is able to expand or shrink as necessary. So that is called elasticity. So therefore, when we build our applications or system, we need to make sure that we are able to create highly scalable, expandable, shrinking capability within our application, within our system. Okay, this is the conceptual concept. Now let us take a look at how can we do this in real world. How can we create applications that are elastic? How can we provision resources in elastic manner? So let me present one of our software technology. Aneka is a cloud application platform that we developed here and available as a product from Manjrasoft. So this can be used for building, resource intensive elastic application. So first, this Aneka comes with two components. The first one is, software-defined kit, SDK. So this SDK can be used for creating applications using different models of programming. Within Aneka, we support, multiple. The three prominent ones that officially we released. One is called thread model programming, task model programming. Second one, The third one is MapReduce. You can build your application using any of this model programming. So some of you may be already familiar with thread programming in Java. The similar model programming within Aneka, you can create Aneka-based thread application and run it on a highly scalable environment. Of course, Java threads, when you create an application with Java threads, it runs within one server. Your server has multiple cores, you can use all those cores. But what if your application need to support even more number of users that cannot be supported by one server? What do? You cannot expand your application to other servers. Whereas with Aneka-based approach, when you create applications using Aneka threads, you can do it. So that is thread. Then MapReduce is another model of programming, very popular. We support it in Aneka. And the task model is also another popular one. So I will discuss a bit more about this as we go along. Okay, that is SDK. And once you build your application, the application can be deployed either on a private cloud or a public cloud or across multiple private and public cloud in a seamless manner. Soon I will give you some examples of this scenario. Okay, the private cloud can be a cloud that is set up in your GLA university. So you can create a private cloud just by using existing servers and the desktop computers, make that Aneka-based private cloud, use it for teaching, use it for projects. And later on, if you want to use extra resource from public cloud, you can spin on the machine and combine these two. So that is called using public and private clouds in a seamless manner. Okay, and public clouds means the services like infrastructure services provided by Amazon or Microsoft or even the Google also you can rent those virtual machines from them and use them. So there is a second component which makes that happen. That is a resource management scheduling system, the runtime machinery. Yes. So of course, when you're at home, a lot of disturbance come into picture. So suddenly, okay, so I kept it there. Okay, so so there are two capabilities. Now, once you go deep inside Aneka, so Aneka has a container services. These days, the concept of containers is becoming very popular in cloud computing. So within Aneka container, there are multiple services like such as membership management, reservation management, security and say licensing. These are all set of services. Then using the services, we create a task model, thread model, or MapReduce. So like tomorrow, you have a new idea for a application programming. For example, maybe you come out with a very special programming model for IoT application, and you want to implement. You can actually extend Aneka services and implement your own. Or you like when you are deploying applications, you want to deploy those based on privacy requirement. You can plug in a new scheduler and to Aneka that meets your requirement. So that way you can support privacy-aware resource management, privacy-aware computation. So I will give you some of the examples of how some of the users around the world have done it. So this technology is used by many around the world. So today I will just give you briefly how China and also this deep learning was done. There are many applications. So in interest of time, I'll just present two. So first from China, China Southern Railways use it for locomotive design. Then ISRO here in India, they use it for satellite image processing. Washington State University, they use it for creating privacy-aware medical data analytics. So for example, when you have a medical data, within medical data, you have challenges such as privacy requirements, and the medical records can be sensitive records or non-sensitive records. When you have sensitive records, you don't want to send it to public cloud. You want to process them in a local cloud computing environment. Okay, and then the non-sensitive data you can do it on a public cloud. So this Washington State University, they built deep learning approach towards classifying medical records, and then based on the record sensitivity, so they are able to process on a public cloud, remaining they are able to process on a public cloud. Of course, we are in this talk, you see, people are also sharing private information. Maybe. Can you ask some of those people to disable their unmute? Okay, I will do. Let me see if I can do. Okay, so hopefully they did. All right. So this is very difficult to control in the real world. This is a public seminar, and everyone has their own situation. Anyway, so Washington State University is able to deploy medical application within a hospital cloud and also an Amazon cloud based on the data sensitivity. So this is where they have developed a deep learning method, and that method classifies the record and plug to Aneka. Then accordingly Aneka does as per their instruction. If their deep learning method says this is sensitive record, Aneka will only send it to private cloud, otherwise it will public cloud. If you just search for Washington State University Aneka cloud, you will see a detailed discussion on how they did it, and I also put it online on a website. And then deep learn like this, there are many examples. Let me illustrate a little more depth, 2, 3, and then we move to next. So this China Southern Railways, what do they do? So they have various train design scenarios. You know, they do rendering on a 4-core server, and they're using our tool called Design Explorer, and they were using software called Maya. Maya is application for this design evaluation. So when they were doing on a 4-core server, it was taking like 4 days, but they wanted to bring down the time to just say 2 hours. They set up a private cloud using Aneka, and our Design Explorer used to run this application as a SPMD, single program multiple data application model that supported by Aneka. They are able to run on a multiple system network. Here the data they gave us on a single server, it took 80 hours. The same thing they're able to do in 2 hours. Now instead of 2 hours, you might say, now because of urgency, I want result in 10 minutes. What do we do? If you want result in 10 minutes, the local resource takes 2 hours. Then the result they want answer in 10 minutes. What can we do? Within Aneka, there is a QA setting. You can go to Design Explorer, set deadline is equal to 10 minutes. Now the local resource cannot do it in 10 minutes. So we want to rent extra capability from a public cloud, from either Amazon, from Microsoft, or any Indian cloud. So for this, we have to pay for it. So therefore, we have to set a budget limit. You can say deadline is equal to 2 hours, budget is equal to 200 rupees. Deadline is equal to 10 minutes, budget is equal to 200 rupees. So now the system looks into the constraints, deadline, local resource, and the budget limit. Accordingly, it will look into marketplace of cloud services. What is their price? Accordingly, rent the virtual machine, then use them in a seamless manner. So this is the hybrid cloud, how we support in Aneka. Now coming to healthcare. So nowadays, health is an important aspect. So let me briefly present health, and then I will, after that, I will share about AI application. So in case of healthcare, analyzing data. So the sensors, ultimately in hospital, most of the time, they collect the patient data through different kind of sensors. Okay, one of the sensors here that was developed here in Melbourne University was ECG analysis. So here the sensor, but nowadays the sensors are available in marketplace. You can just buy it for just 500 rupees. The sensor that can collect your ECG data, and then you can have an app running on mobile phone. The data transfer to the app, and from there you send it to cloud where application as a service available. Say for example, ECG as a software service, application service which you can run and serve the users. So initially, when you have, let's say you are a such healthcare service provider running on Aneka on top of say Amazon or Azure or whichever. So now when the application is running, initially you might have few customers asking for this healthcare data analytics. You might say, yes, every request are issued from the users. I will answer them within 1 minute. Take the healthcare data, process it, and give the response back within a minute. That is your quality of service promise that you made. Then, of course, for which they pay 5 rupees. Now, we have number of users increase more and more and more expensive. So the resource that you provision is not able to meet the requirement. What do we do? So we have to dynamically add extra resource if in a public cloud. So Aneka support the dynamic resource provisioning based on QoS promises that are made to users. So this is a healthcare application where we are able to combine, sensing, the mobility, and the cloud. The cloud means the services and the platform and also infrastructure. So this was demonstrated, and we regularly demonstrate the cloud-centric healthcare service. You can see we connected the sensor to person hand, from their data went to cloud, where they send it to from mobile phone to cloud, where processing is done, results come back, and you can see different graphs on that mobile phone. So this graph can be used for for various purposes. Say for example, one of these graph can be used to find out how many hours person has slept yesterday night. So this can be very useful information in terms of deciding who can join the seminar. If somebody has not slept at all yesterday night, there is no point in having them. Otherwise, they will be just sitting in a computer and sleeping, correct? And their phone is ringing and making noise. So it can be adversely controlled. But other cases, like depend upon our health scenario, how much exercise we have to do, or what is our body situation like. So all that can be analyzed, and then that can be reported without actual consulting to the physical doctor. So instead, healthcare analytics. So that is about healthcare. Now coming to object detection. So these days, AI and deep learning has become very popular. So the skills in the industry, they are seeking people with excellent skills in machine learning, AI, deep learning methods. And here we did one work on object detection. Like for example, lots of vehicles are moving on the road, and this object detection can be very useful, especially in COVID situation. In COVID situation, everywhere control. So they are saying people cannot walk on the street, cannot assemble too much, maintain social distance. Then how do we enforce? Of course, in India, they have police everywhere running, and we see photos where they're trying to chase people. Whereas in Australia, there is no such thing. They just, let people expect that they automatically follow. If they notice through camera, then they, issue a big fine of like $1,000 per person. That will be like 50,000 rupees, very expensive. Anyway, so if you have cameras in different places, cameras are monitoring. So it can be useful to find out how many people are on the road. And who are they? Object detection. Is it car? Is it human? Or is it a mouse or a dog? Whatever. The different type of things are moving around. So here is an example where we did deep learning library. So there are deep learning library that classify records, that classify objects. The photos are taken through, say, camera and comes to a device, and then yes. So here is one person, Chitrisri, muted, and we can hear what they're doing. Maybe they're drinking coffee or tea, hopefully. All right. So now coming to this object detection, here, so there is already a object detection library available in Python. So we took that Python library for object detection and made that the Aneka task. When number of images are coming in through this, say cameras, then we process that in parallel by using resources, local resource and remote resources. In one of our experiments we written a detailed paper on this. So here, Aneka server running on Aneka worker on server one, worker on another one. Then we have another worker on, this is in Azure, another worker on Amazon. So when the request comes in, so initially try to do all this deep learning for the detection on the local resource. When extra resource necessary, to use that extra together, and finally use back result. So here when we feed a original image like this in a computer lab, then after processing, it is able to display, it is able to low latency output or high latency output. In case of high accuracy, you can see it classified. Oh, these many monitors, these many chairs, these many mouse, these many keyboards, monitor. Then other places bit less quality. But anyway, you can see this is very useful in universities also to find out how many students are in the lab. So how many persons are, do you have all the computers in the hub? Did somebody take away some computer? So all that can be just by having this camera monitoring, and then you can detect. So this will be fantastic application if it was done in a scalable manner, and then it deployed in different cities in India. I think we don't need so many police. They can easily detect where are the assembly of people and where they're not following the rules, social distancing, where they are, even though government put rules, but nobody follows, or some are following. So you can detect them and monitor and manage them. So this is one example of object detection. So this application of object detection can be useful in so many areas, including security, enforcing rules and regulation, perhaps maintaining, spread of this epidemic spread can be controlled, managed, regulated through such application. So I think this is something I'm encouraging. Maybe some of the students can perhaps take up such project right now, do it on Aneka. Okay, so the Aneka software, so I can just speak this for a one semester course. But anyway, in interest of time, so if you want to learn Aneka, explore a little bit yourself, visit manjrasoft.com, then download and explore. So there are many students out of the world did interesting applications. They downloaded, wrote their own application, and some of them published short papers, some of them published serious papers on our Manjrasoft website. If you visit Manjrasoft website, and then you will find at about in publication, you will see many example, this discussed. In fact, this object detection one is also paper is there online. You can explore. And And of course, there are many universities around the world, in China especially, teaching courses that uses Aneka. But in India in particular, this is interesting. So you can see the many universities throughout India have introduced cloud computing curriculum, and quite a bit of them have set up Aneka-based laboratory and then teaching courses in this area. Then, of course, I understand that this IBM, the curriculum on BTech computer science, which specializes in cloud computing, that also has a subject called cloud application programming. And if you open up that cloud application programming very depth, you will notice that that content is actually coming from our book, Mastering Cloud Computing, and the lab exercise. I hope you will be doing soon. So that is actually done through Aneka, Aneka-based laboratory programming. So we are pleased that now countrywide, so there are many installations of Aneka. Universities have set up private cloud laboratories and using it for teaching subject in cloud computing. So that is about cloud computing challenges, how it is supported in Aneka with a few applications. So now let me look into this IoT, Internet of Things. Why this is so important now and why it became popular. As I said in the beginning, Internet is networks of computers, and that concept has moved to networks of everything. So what are those things? Things can be the roads, things can be temple, things can be with the camera at a home, things can be a watch that I'm wearing. So I am just wearing Hanumanji band. Hanumanji can be a protector, but I can wear a electronics IoT watch that can monitor my data, heartbeat data, to see how I'm doing. Correct? So these are the different things. And when we have these things, what can we do? We can create many interesting applications: smart healthcare, smart agriculture, smart transport, smart cities, everything smart. Anyway, so here is the data that talks about right now 50 billion objects are online. By 2030, so my aim is to discuss you about 2030. This will double, 10 times more. So when you have massive number of such objects available, then if you now build the application that are cloud centric, what happens? If all of these billions of objects pushing data to cloud, what happens? The internet gets clogged. Not only internet gets clogged, the response time, latency will be very high. So this is where we need to look into different model of computing. And meanwhile, in terms of economic opportunity, in 5 years' time, by 2025, $11 trillion opportunities available for exploring this IoT-based application opportunity and impact. So this is a great thing. That is why IoT is also considered as one of the important area. And this IoT is being adopted for many applications around the world. Then what are those applications? So you can see there are many of these interesting applications of this IoT. Okay, somebody's drawing. No, okay. So you can see IoT applications in home. You can make smart home. So what is this smart home means? Managing what resources are consumed at home, when to turn on the heater, when to turn off, or when to, or fridge, for example, if your fridge is part of IoT, it may send you a SMS message saying that, hey, we are running out of following vegetables or the milk at our home. So like that. So making it smoother or also secure. Then the healthcare, which I talked about, smart city. So like this, many applications are there of this IoT. And that is why we need a new class of computing paradigm. So this is where comes fog and edge computing. So let me make it more clear. So in case of the traditional one, the first one is the cloud-centric IoT application. The few applications that we saw earlier was the cloud-centric. So, but with the emergence of so many IoTs, if you try to push all the data to cloud, what happens? The internet gets clogged and latency will be high. So to overcome that limitation, the new model, that is fog and edge computing, came into picture. What is this fog edge computing? Is instead of pushing data to a cloud, a remote centralized place, we can harness the resources in the edge of the network, like the resources at home, resources at the office, harness them along with the cloud as necessary. That is called edge and fog computing. So just using edge resource is a pure edge. Then if you are using both edge and the fog in a seamless manner, that is called fog computing. Okay. And then when we say fog computing, how does it look like? So at the top, at the end, we have cloud infrastructure. And then at the beginning, we have IoT devices. the request comes in, there will be a gateway node, where gateway node can be your mobile phone, and then from there, data sent to a cloud computing brokering environment. So here is a cloud resource broker which receives the request, accordingly find out what resources are the locally, what the resources in the core of the network, what resources in the cloud, accordingly use them and deliver capability to the users. So this is the conceptual diagram. And in this direction, we developed a software called FogBus. FogBus is a software framework for creating edge and fog computing applications where you can deliver those services with the low latency requirement. Plus also in this case, you also have a trustability. When I use resources from different places, can I trust the results? So this trustability is these days assured through blockchain. You know, blockchain is popularly became popular in the context of digital currency like bitcoins, but the same blockchain can be used for various purposes, and one of them is this enhancing trustable results in the care of healthcare. So we added blocks to the task. So here is the user, you know, the oximeter, for example, healthcare, the data comes to the gateway, which is a mobile phone on which app is running. That makes a request to a broker, which is a FogBus resource broker. FogBus resource broker can use the local edge resources, and edge resources can be a not big computer like laptop or servers. It can be a Raspberry Pi. Raspberry Pi is a small matchbox size computer available for say 500 rupees. That matchbox like computer can be used to run various small scale workers of FogBus. Then use it for creating low latency oriented, real-time oriented applications and run that locally. And then of course, sometimes you need a public cloud access also. So we linked. So if the local resource is unable to meet, it will spin a task on Azure or any other public cloud using Aneka. So this is linked with Aneka also. So that way, both the edge computing resource and the cloud resource can be used in a seamless manner. That is through FogBus. And of course, let me show you with one example with healthcare. So of course, healthcare is one of the popular area. So IoT-based healthcare solutions, and this can be used for health system management at the hospital or the remote healthcare, like which we saw like ECG monitoring, blood pressure monitoring, oxygen. There are many interesting applications that patient can be there in a remote home, and then the data collected and processed. So here is one. This is another interesting application called sleep apnea analysis. Like people are sleeping. Sometimes people sleep there. Sometimes they get choked. So this is called sleep apnea problem. So how do we detect and manage it? So here are some healthcare sensor like oximeter that you can tie finger to your finger and sleep. And of course, it monitors your data, and the data can be sent to application. So here is one application called sleep apnea analysis. So this data that we process and send it to the processing there, and that application is able to tell us what is the state of this person. So the situation like sleep apnea problem, is it mild, is it normal, is it severe? If it is normal, no need to worry. If it is mild, maybe at some point in few months time, you must see the doctor and see what you can do, how to overcome the problem. And if it is very severe, in system is to detect that, okay, if this person is not taken care within half an hour, he might die. So that emergency signal raising and action. So this is a very interesting healthcare application where we are able to combine, all these capability. And this was the demo that we have shown. You can see we connected this sensor to person hand, then data collected and processed, and we had a edge cloud, edge capability. So these are the Raspberry Pis that we use and created the edge resource. Of course, if it is a nice one, there will be a small box. You can have a small box at home in the corner, small box at the signaling system, at the transport system that can help detect and then do things, do this analytics and then give you results very fast. So this is the combining. So that is about healthcare. And we also have a simulator called IFOG that is mostly for those who want to do research or PhD. So instead of building the real stuff, you can do modeling and simulation. So we have a new software called IFOG. So earlier for cloud computing, we had something called Cloud Sim. It's a simulator for cloud computing. IFOG is a simulator for fog and edge computing. So particularly targeting IoT applications. Okay, so that is so if you search for IFOG on internet, you will find both software and many example application systems and others innovation people around the world have done it. Okay, so let me summarize and talk about future direction. Then after that, we can have a question answer session. To summarize, there are several computing paradigms have promised this vision of how to make computing as utility. So today we got cloud computing that turned this vision into reality. Then of course, with rapid adoption of cloud computing, the need for multi-cloud is created many more opportunity for innovate. But meanwhile, existing infrastructure that is created is already used for creating many exciting applications that are used in day to day. So Aneka, we also discussed how it supports this elasticity. Elasticity is the important feature. And in a market-oriented where user define the requirement in terms of deadline, time, in terms of price they are willing to pay, accordingly the system rent the resource for you in the marketplace and deliver service to you. So Aneka is popular for building applications rapidly. So here our focus is how can we minimize the cost of software engineering. If you want to create application, you should be able to set up very quickly. So if you search on internet, you search for Aneka and cloud computing and the paper, research paper, you will come across many interesting smartphone paper done by undergraduate students. Even though they may be small scale, but they set up themselves quickly, then learn and then created some deep learning or machine learning algorithm and wrote smartphone paper also. So the applications of Aneka in many areas, I have discussed briefly from China, so engineering application, healthcare also briefly, but there are many more like gaming application, network games, highly scalable network games, examples, business analytics, AI. So in interest of time, I didn't present, but you can read more in the book. So this Internet of Things, of course, is driving new innovation. So the first generation Internet of Things were cloud-centric, but now the next generation has to be really edge-centric or fog-centric. Edge means the pure edge resource, cloud means the pure cloud, the fog means using both the edge and the cloud together. So this way we can reduce the burden on the internet, reduce the load of the internet, then also create applications that are low latency, that means real-time oriented application. So looking into the future, so last year we put together this manifesto for future generation cloud computing. So there you will see there are many, many open challenges. I will just give briefly one of them, but there are many open challenges from all angles of cloud computing. At the level of heterogeneity of different hardware. Like these days, you probably heard something called TPU, transaction processing unit, and then FPGA and GPUs. Different type of hardware are coming. How do you use them in a seamless manner? Next, how do we manage security? Then how do we manage privacy? Then how do you manage scale across multiple cloud data center? And how do you manage the energy consumption of the cloud data center? And how do you deal with multiple computing users? Then how do you deal with when you scale across multiple devices? How do you manage the failures? Okay, if it fails one place, how do we seamlessly scale across? So these are challenges that are discussed in this article. You can see the contributions for this article come from experts around the world that are listed here. So one of the challenges called holistic resource management. So in cloud, there are varieties of resources: compute resource, network resource, applications, data management, centralized. Then the energy sources can be, brown energy or the renewable energy. And then of course, the consumers of resource, not only compute and network, but also air conditioning system. So how do we manage the holistic manner? So this is one of the important big challenge open for some of you to explore in the future. And to learn more about cloud computing, to start with, here is our book, Mastering Cloud Computing. So this is the American edition. So this cost you around $100 US. I think right now $100 US is probably close to 8,000 rupees. Not affordable in India. So we have Indian solution, which is just for 400 or 500 rupees. You can buy it from McGraw Hill in India. The same book, same content. But of course, there is the different publishers have edited it differently, they presented differently to the audience. But overall, it is the same, 90%, it is similar. Okay, so that is for Indian audience for 500 rupees. But American audience, 8,000 rupees. But if you want to take the same book to the China, that is $3. $100, like $8, and then $3. So Chinese edition. So in a Chinese language. So the book is also available. So in China, it is popularly used. That is for cloud computing. Then regarding IoT, so we published a book through Elsevier called Internet of Things. That's also available. Then recently, this few months, actually almost a year ago, the edge computing book also published and released in the marketplace, where you can study more about, especially edge and fog. These are moving target. Lot of advances necessary. even my this other book that our cloud computing, this book, if you see the last chapter, it discusses about future directions. And there are so many open issues that are available. So some of you who become expert today in the today's technology, then based on this, you can look in the future direction and do advances, extend the technology, create new application, create new approach to the way applications are created. All those are open directions. This is up, for some of you who want to do project, you can explore. Okay, so let me stop here, and thank you very much for your patient hearing. Okay, so I will stop, and of course here are my contacts. So you are most welcome to contact us by email or other way. But meanwhile, what I will do is I will stop here. Then I will let you ask questions, either typing in a chat room, or you can ask if you can manage. Thank you very much. Thank you.